So how do you graph systems of linear inequalities? Farmer Quirt wanted to sell some guespables and looks at the market. He could sell at most 6 units. He planned to charge $3 per guespable and $6 per look. He expected to make at least $24. So we can write a system of statements modeling the relationships between the amount of guespables X and the amount of looks Y. Remember that this is a system, so it has 2 or more rules. Our first rule is X plus Y is less than or equal to 6. And that is because he could sell at most, which means less than or equal to, 6 units. And our units are the guespables and the looks, so this is X plus Y is less than or equal to 6. Additionally, we would have 3X plus 6Y is greater than or equal to 24 because he was charging $3 per guespable, $6 per look, and that had to be greater than or equal to because it says at least 24. So here our system only has 2 inequalities, and we're going to take a look at graphing this system. Notice how again it makes no sense for us to have negative guespables or negative looks or make negative money. So we are limited to just the first quadrant. We allowed our X variable to represent the number of guespables, and remember this is going to increase by 2, so we'll have 0, 2, 4, 6, 8, 10, 12 along our x-axis. That's what the 2 in parentheses means, that we're increasing by 2 each time. And then the looks, since we don't have a parenthesis there, these are going to increase by 1 each time. So we'll graph the first inequality, x plus y is less than or equal to 6. We do this by using a table, and we always want to make sure, if possible, that we allow both x and y to be 0. So here when x is 0, y must be 6, and when y is 0, we substitute 0 in for y, x must be 6. We can then graph the points 0, 6, and 6, 0, and connect them using a segment. Remember that we use a segment because we have 2 endpoints. Are we going to shade this above or below? Well, because we have less than or equal to, we want to shade below. So we want to shade that triangle formed by the axes and our line. Then we want to graph 3x plus 6y is greater than or equal to 24. So here we can make another table. Again, we want to give both x and y the chance to be 0 so we can see what our intercepts are and make it easier to graph. So if we let x be 0, our 3x terms disappears because 3 times 0 is 0. So 6y must be greater than or equal to 24. 6 times 4 gives me 24, so y must be 4. Similarly, if we substitute 0 in for y, we're just left with 3x being greater than or equal to 24. That means that x must be 8 because 3 times 8 is 24. So we can graph the points 0, 4, and 8, 0, and connect them using a segment because we have 2 endpoints. Do we want to shade above or below for this line? Well, again, we look at our symbol and it says greater than or equal to, which indicates that we want to shade above this line. So we shade above. Remember, our solution region is that part where both of the colors overlap, so it is this blue triangular shaped section between those 2 lines. That is our solution to the system of inequalities. So this is where all of the possible points that satisfy both inequalities lie. Let's look at another example. Farmer Aliber wanted to sell some shoebles and jupes at the market. She needed to sell at least 20 units. She planned to charge $7 per shoeble and $3 per jupe. She expected to make at most $84. She could sell at most 3 shoebles. So we will write a system of statements modeling the relationships between the amount of shoebles and the amount of jupes. So first we have x plus y is greater than or equal to 20, and this comes because she needs to sell at least 20 units. She planned to charge $7 per shoeble, so 7x, plus $3 per jupe, 3y, and this needed to be at most, so less than or equal to 84. And finally, she could sell at most 3 shoebles. Since shoebles is our x variable, we will have x is less than or equal to 3. Let's go ahead and graph this system. So again, we're limited to the first quadrant. We have shoebles. Shoebles are going to increase along the x-axis in increments of 5, and jupes will also increase along the y-axis in increments of 5. We can make tables to test solutions here. So here we can choose anything such that x is less than or equal to 3. So here we'll just have 3 for both of them, and then we can choose 0 and 15. Really, we could choose anything for y as long as our x value is always 3. So let's go ahead and plot the points 3, 0 and 3, 15. And then of course we connect these with a ray. Notice that this is not starting at one axis and ending on the other, so it only has one endpoint because it only has one intercept. Therefore we need a ray to show that that continues on indefinitely. Do we want to shade above or below? In this case, we think of above as to the right and below as to the left because our line goes straight up and down. Notice our inequality symbol is less than. That indicates to the left. So let's take a look then at our units inequality. So again, we have x plus y is greater than or equal to 20. This is a nice situation where we can allow both x and y to be 0. So when x is 0, y must be 20, and when y is 0, x must be 20. So we can plot the points 0, 20 and 20, 0, connecting them with a segment because they have 2 endpoints. So we want to shade above or do we want to shade below? Looking at our symbol, we see that we should shade above because we have greater than or equal to. So we shade above. Finally, we can look at our final inequality. So 7x plus 3y is less than or equal to 84. Again, we'll let x and y both be 0. When we substitute in 0 for x, we get a y value of 28. And when we substitute in a y value of 0, we obtain an x value of 12. We can plot the points 0, 28 and 12, 0, connecting them with a segment. Do we want to shade above or below? Well, here because we have a less than or equal to sign, we want to shade below. So we can shade below. Now we want to look for the section that has all 3 colors of shading in it. And in fact, that is this little trapezoid shaped section right here. So this is the location of all possible points that satisfy the inequalities.